Okay, here's problem number 59. I need your cooperation and your silence as we get this recording done. Okay, a couple of questions before we do this. I want to talk in general. What order polynomial do we expect that this is going to lead to? When I'm looking for points of inflection, I'm looking at the second derivative.
Yeah.
What order polynomial are we going to get?
Cubic.
Third power, or third order, or cubic. Great. We don't like cubics. We like quadratics because we got great tools for it, but we don't like cubics necessarily. 5x to the fourth minus 20x cubed plus 3. Y double prime is 20x cubed minus 60x squared. Y double, let's factor out a squared, leaving us 20. No, let's factor out 20 squared.
20x.
Thank you, 20x squared, leaving us x minus 3. Are we good there?
Yeah.
Okay, now here we go for the answer, going for the answer. If we look at the y double prime function, we see that there's a 0 at 0, and we see that there's going to be a 0 at 3. Agreed?
Yes.
Okay. Someone who's just going through the motions, though, are going to say the inflection points are at 0 and 3. But if you do something like, when x is really, really large, what kind of values do we get out? We get positive values. When x is really big and negative, what kind of values we get out? This part's going to be positive, but that part's going to be negative. We got a negative there. And then when we choose a number between 0 and 3, how about the number 1?
Okay.
I get a positive here, and I get a negative there. We get a negative values there.
No sign change.
Since there's no sign change at 0, there's no inflection point at 0. The only inflection point will happen then at 3, so the right answer is C. Now, to say this another way,
If we want to find the actual point, though.
hold on. Well, it didn't ask for it. It only asked for the x coordinates, so it's cool. And if we wanted to find the actual point, we plug that 3 back into the original equation. One of the reasons why I knew before we even started plugging in numbers that there was no sign change at 0 is I would say that there was a double root at 0. In our second derivative, you see it's x squared. When there's even roots or an even power there, they cause no sign change at those locations. When there are odd roots, for example, x minus 3 has an exponent of 1 there. When there's odd roots, there are changes. So I can tell without plugging the numbers in that there wasn't going to be a sign change at 0.
Wait, Will, can you repeat that? Because I feel that was
Sure.
really important. I didn't get it.
Okay. The fact that this exponent is even means that there will not be a sign change as we go from one side of this 0 to the other. And it doesn't matter that it's 2, it matters that it's even. This exponent here is odd, and it doesn't matter that it's 1, it matters that it's odd. There are sign changes where there are odd exponents. And this only has to do with polynomials, but by inspection you can just say, oh, even double root, no sign change. Odd, single root, there is a sign change. And that can save you a little bit of time that you don't have to do the number line thing. Gunnar, this is your question. We good?
Yes, I'm fantastic.
All right, there we go.
Is he immortal times 2